All right, I've come in from the greenhouse where we collected the nutrient solution that was being emptied from the individual emitter, and then also we collected some of the leachate that had gone all the way through the vertical tower that had basal in it. So I want to work through a couple of things to try to help us to refine and make sure that we know where we are in our nutrient solution measurements. So with me today, I've got an electrical conductivity meter here that'll help me to measure the total salts that are dissolved in that solution. And it's a total measurement. The more salts that are in the water, the higher the electrical conductivity reading is going to be. But I don't really know what specific nutrients may be higher or lower. So to take it one step further, I've got a couple of meters here. These have ion selective electrodes in the little spoon part of this. I have one that measures nitrate nitrogen and the other one that measures potassium. So the EC may be perfect, but I want to make sure that I've got the right amount of nitrogen and the right amount of potassium as well. So to set these up, there's a calibration. I already have the potassium one calibrated, but I want to take you through the process here. And we're going to start with turning this meter on, and then it's ready to go through a calibration process. And I'm going to put some known solution on here. It's 150 parts per million of nitrate, which converts to 34 parts per million of nitrate nitrogen. I'm going to push the calibration button, and it's set up for the nitrate nitrogen mode, and so I want it to be able to settle on 34 parts per million nitrate nitrogen, which it has. There's a little symbol on here that blinks to let me know that it's in the calibration mode. Once it reaches the final number, then it gives me a little smiley face so that I know that it's set up and properly calibrated for that particular nutrient. And then I have a second standard, which gives me more precise calibration of this meter. And I do the same thing. I push the calibration button until it starts blinking. And in this case, it should read 450 parts per million of nitrate nitrogen. And when it gives me the little smiley face, I know it's set, which now it has done. So this meter has been calibrated, set, and ready to go. And I've already done the same process on the potassium meter, which is the same basic steps with some other known solutions that we start with there. So if I want to start with a solution that came out of the emitter at the top of the tower, I'm going to start with this EC meter. I'm going to set it in here, and it is reading at about, let it get settled down here, about 1.9 on my EC meter. So after that solution, I've got some distilled water here that I'm going to rinse this meter. And so I'm starting out with 1.9 EC on the incoming. And then after everything went through the towers, I'm going to have another reading here. And it is just a little bit higher, but very, very similar at maybe around 2.0 on the EC. So it has not changed very much from the incoming side of it. So that's the way that we could measure an EC. And I would say that every greenhouse grower, large or small, especially the smaller growers, need to at least have the ability to take a reading for electrical conductivity and pH. The one step further that I like to be able to do is to take it to the next level where I can measure the incoming for nitrate nitrogen. And I'm going to put a little bit of solution to cover those electrodes, and then I'm going to push measure on these two and let it settle down for the final reading. And it has given me the little smiley face now, so it's reading at 110 parts per million of nitrate nitrogen, which earlier we had stated that our target was going to be about 120. And also on the potassium, we're seeing a reading here of about 160 parts per million of potassium on the incoming side. So those are not a surprise to me, and I'm actually okay with the fact that it's 110 instead of 120 because the temperatures are so high. I'm really not concerned at all about it being just a slight bit less than that. These meters are not going to be able to tell me anything between 110 and 120, so it could actually be 115, but the sensitivity here is only going to take it to every 10 parts per million. So now I've got the solution that went through, and this was after several irrigation events. This is the leachate that came out of the bottom of the container over a period of a couple of hours. And so I'm going to have the measurement here. And on the nitrate nitrogen, it's reading 120. So it's just a little bit higher in nitrogen coming out of the bottom than what was coming in at the top, and we'll talk about that in a moment. On the potassium, it's reading 170. So my summary of this would be that the incoming and the leachate are very similar. And so I think that we're pretty much on target for where we want to be. But I'm aware now that in these high temperatures that it's taking a lot of water. And so what's coming out of the bottom of the tower is just a tad bit more concentrated because it's picking up more water, in a simple term, more water than it is nitrogen or potassium. So if that were to continue to rise, if the leachate numbers were to go to 220 or 30 or 40, or if the nitrate would go to 150 or 160 or 170, I would begin to get very concerned that I'm not putting enough water in the system. So it would mean that I'm probably not irrigating frequently enough, or I'm not irrigating at a long enough duration, but I need more water. The other thing that I could do if I really get concerned about that is that I could drop the EC of the incoming solution a little bit until I get things back under control. I'm not a big fan of turning off the nutrient solution entirely and flushing out an entire tower. I feel like if we can just keep it at the proper level to start with, we have less risk of doing that. And so here in Florida, we tend to have a lot lower EC, a lot lower nitrogen, a lot lower potassium than other parts of our continent, really. So if you go up into Canada or other parts where the solutions may be a lot higher in concentration that would be recommended, Florida is entirely different. So oftentimes I get concerned because we have such ready access to information all over the world, and I want to make sure that it applies to what we're doing here in Florida. So in Florida, because we have such high uptake of water from very early in the morning, as soon as the sun comes up until the sun comes down, very high temperatures, we tend to be able to target lower concentrations and maybe a little bit more watering events over the course of the day as well. So I'm actually really happy with this. It's 110 coming in, 120 going out on the nitrogen. I'm pretty good with that. I would say if we can maintain, maybe no more than a 20% change in that, either up or down, that I'm going to be pretty satisfied with that. If by chance this went in the other direction, where instead of having higher concentrations, we had lower concentrations of nitrogen or potassium, it would trigger me to think about it differently. It would think about that maybe I need to increase the EC by increasing my A mix and B mix, and maybe have a target of 130 instead of 120, so that I can pick that up a little bit. But without some knowledge of what's going in or what's coming out, it's really a shot in the dark, and it's pretty simple at least to get the EC measurement so that you know on the big picture how good you're doing. But it does give you one piece of risk, and that is you don't know whether the nitrogen or the potassium are at the right level. The other thing that I would do with this ability to collect the leachate, I want to collect the leachate over the period of an entire day, because each individual irrigation event in the morning or the afternoon is perhaps going to result in different levels of leachate that comes out of the bottom of the tower in this instance. But if I know how much went in over a period of the day and how much came out, let's say that if this was a whole day's worth of leachate and it's about 3 ounces or just a little bit less than 100 mils, then I would want that leachate to be, in terms of volume, somewhere in the neighborhood of 10 or 15% of what went in. All right. That's the numbers that are recommended for us here in Florida. That might be different, very different, where you are in terms of and what your environmental conditions are. But for us here in Florida, diluters, more dilute solutions, and we want to have something in the neighborhood of 10 or 15%, maybe no more than 20% leachate coming out of the bottom of the tower. I would use these same principles if we were using a slab of rock wool or a slab of coconut fiber, a bag filled with perlite, a pot filled with some type of a substrate. The principles that I've just gone over here are going to be the same from one type of substrate to the next. You need to know how much is coming in, what the concentration is going in. You need to know how much is coming out and what the concentration is of what's coming out. Then you can make some sensible decisions, educated decisions about how to fine tune what you have. So it's a relatively simple process once you get used to using these meters. I love these meters. They've made me probably look a lot smarter than I may actually be because they give me real numbers that I can talk with the growers about and help them to make some good decisions. We also can use plant petiole sap on these same meters. And so whatever we put on this meter as a solution, it's going to tell us what the nitrate nitrogen is or what the potassium is on this one. So these are very versatile units. If you get the two of these units together with all of the cutting board and this garlic press and things like that to do petiole sap, you're probably going to have about $1,000 in that entire kit, which might seem like a lot of money, but you can save a lot of money on fertilizer in a hurry in a hydroponic system by being able to fine tune it. So that's my little lab exercise here for today. Really helpful in helping us fine tune things. The thing that I take away is Wanda's got it right on the money where she needs to be in terms of what's coming into that greenhouse with the towers of the herbs.